Okay, so we just finished calculating the RMSE for the linear equation, and here it is. Now on our main sheet right here, we have our linear RMSE. Notice it's already right there. And here's our same XY values. Let's make these pretty like the other ones. Okay, so how did I get this to appear right here automatically? I didn't actually copy and paste that in. It was actually ready to go. So I am in this cell referencing the cell on this linear sheet, and it's literally just calling upon the cell that has the RMSE in the linear sheet. So let's say you don't know how to do that. I'll show you right now. Referencing is it's a great thing to be able to do in Google Sheets because it allows you to basically call on a cell on another sheet. So let's do it. And the way you do it is you first type the name of the sheet with an exclamation mark. So linear exclamation mark. Then you type the cell from that sheet you want. So let's go see what cell we want. Let's look at the linear sheet. We want this cell. That is cell I13. I13. So let's come back here. We're going to say, we'll fix that error. It says equals linear exclamation mark I13. And then hit enter, and it's actually pulling this value right here into this sheet. We are going to end up doing that for all of our RMSEs that we're going to calculate in a minute. So there's our RMSE for the linear. Let's get on with it and see how the quadratic works out. So here's our quadratic sheet. And this is interesting. You know, what I actually did is I just copied and pasted all this. So this prediction is the linear prediction, where it's using bx mx plus the starting value a. And I don't want to use a linear model here. Of course, I want to use a quadratic model. So I'm going to delete this. I'm going to delete this. And then, of course, these will also, all these predictions we're going to redo because they're going to be the quadratic predictions. Interestingly, these residuals are still ready to go. So if you just copied f2 minus g2 for the residuals, what it's doing here is it's subtracting f2, which is 3, minus g2, which is nothing. So it's just getting 3. So if you notice, the residuals here are all the same as the y values because there's no predictions yet. So these residuals will change as soon as we get our predictions going. Also, the residuals squared they're just h2 squared, and it's ready to go. But of course, these residuals will change, so these residuals squared will change. Let's get on with it and find the quadratic equation. Not the quadratic formula. We're finding a quadratic equation that represents this data set. The mean and standard deviation was needed for the linear equation. We don't need it for the quadratic equation, so we'll delete these. These are ready to go for us, and we might change those. What am I saying? Those will change naturally as we enter the rest of the data. Okay, let's calculate the quadratic. Now, calculating a quadratic regression is more complex than a linear regression. So in the linear regression, how there was a formula that we learned, we actually don't learn a formula in this class for the quadratic regression, and we're just going to have Google do all the work. So the way we're going to have Google do all the work is we're going to go just insert a chart and have the trend line appear on the chart with the equation. So let's do it. Here I'm selecting the data, and now I'm selecting insert, and I go insert chart. And good, it's using column E as labels. Here we see our scatter plot, and that's all fine. Now what we want to do is go to customize. We want to go to series, and in series is where it has the trend line option. Let's turn that trend line on. Let's give it a color, and let's put a label, and this is essential because the label is where we're going to see the equation. And the equation right now is a linear equation. So let's scroll down or up. There it is, linear. And what do we want? We want a quadratic, not a linear. Well, a quadratic is a polynomial. So we want a polynomial, and a quadratic is a polynomial of degree 2. And notice, very nice. Here is our quadratic, a nice parabola appears. And here is our quadratic equation. So it's ready to go for us. And now we can use this quadratic equation to to produce predictions. So here we go. Let's go on. I'm going to resize this so that it fits right here. And to produce our predictions, what we really want is we want to be able to call on the a, b, and c of the quadratic equation, the ax squared plus bx plus c. We want to be able to plug into that. And so the essential thing there is the coefficients, the a, the b, and the c. So this part you unfortunately, as far as I know, have to do by hand. So let's get our a, our b, and our c values going. Our a value is the coefficient on the x squared. So that is 0.0347. So this is 0.0347. Our b value is the coefficient on the x value. So that's negative 0.168. And it's very important to get the negative, of course, or everything will be off. And then the c is the number that appears first here, which is the 3.41. All right. Now, with these values, we can now calculate our predictions. So what are our predictions? They're going to take these x values and plug them into this quadratic equation. So let's set it up right here, and let's do the first one. So we want our prediction to be ax squared plus bx plus c. So a times x squared. A, we're going to call on that cell, and that's cell A13. So that's our a value, times x squared. So our x value is in E2, and we want that to be squared because it's ax squared. All right, plus bx plus c. Our plus bx, so b is in B13, times our x value, which is E2, plus now, so we have ax squared right here, plus bx, and now plus c. And the c we are going to call upon, and that's cell C13. Now you might ask, why not just put 3.41 here? See, the nice thing about this whole process is that it allows us to change one thing, and then everything is recalculated for us. So it's actually quite a powerful tool we're learning how to use. So there we go. There's our prediction. And that's a good feeling because our prediction, 3.2, is close to our y value. Kind of tells us that we're on the right track. I notice our residual is already calculated because it's f2 minus g2. And the residual and the residual squared, that process and the rest of the RMSE is all the same as in the linear. The thing that's different is that here our prediction is coming from ax squared plus bx plus c. In the linear one, our prediction was coming from a plus bx, a linear equation. Now we're using a quadratic equation to get a different prediction. So the process of residuals and the RMSE is the same, but our RMSE and our residuals are different because our predictions are different because we're using a different equation to make predictions. Let's finish these predictions. Now we could just take this, copy, and paste it, but hold on. We have to make sure we lock on to the values we want to lock on. So we're going to put $signs on our a, b, and c values because we want to keep those on the same values. Notice I'm not putting $signs on E2 because those are the x values that we want to move when we paste downward. So we have our $signs set up well. That looks good. That didn't change, but now when we copy paste it, it will stay locked. That looks good. Our predictions are close to our y values, and it seemed to all work. All right, so far so good. Now here's our residuals. Here's our residual squared. And here's our sum of residuals squared, the sum I2 to I9. And then here's our RMSE. Now, right here, notice that's the STEYX. That's calculating the RMSE of the linear. And so that's the old RMSE of the linear. We're in the quadratic one, so we're going to delete it. Don't worry, if we go to the linear, it's still there. Oh, wait. We never did that. Let's do it now. We want to make sure that our RMSE is done correctly for the linear. So I'm in the linear one. And the trick there is to type equals STEYX. And that command calculates the RMSE for you. But it only does it for the linear model. It doesn't do it for the quadratic. So it's going to do the RMSE for the linear automatically. We're going to go F2 to F9, the same data set again, comma E2 to E9, and there it is. And notice that STEYX, the RMSE calculated from Google Sheets, is the same as our linear regression, our linear RMSE that we calculated with all the steps. So that definitely tells us we did our RMSE for our linear right. Back to the quadratic does not have that function. So we kind of just have to trust our process here. All right, so there is our RMSE for the quadratic. And let's go back to our main sheet and get that RMSE in here. So we're going to type equals quadratic, exclamation mark, and I believe it was I13. Yep, there it is. And notice, now it's getting interesting. Our RMSE for our quadratic is much smaller than our RMSE for our linear. What does that mean? That means that our quadratic has less error. Why does our quadratic have less error? Because the quadratic is producing a curved equation, a curved line that goes through the data, so it can fit to this data more easily and with less distance between the line and the points. The linear is producing a straight line, and so it's producing more error in this case. Notice that our data is kind of naturally quadratic. If our data was naturally more linear, then a linear might be more accurate. However, I'm not sure. Perhaps a quadratic regression is always more accurate, because a quadratic regression, if it wants, can become a linear regression by just having the x squared be 0. So I'm actually not sure about that. The quadratic might always be better than the linear. Well, in this case, for sure, the quadratic is more accurate because the quadratic has a smaller RMSE with less error. Let's get on with it and find the RMSE of the exponential regression. So let's create our exponential regression. Let's go here. We don't need the mean and the standard deviation. We're going to delete these predictions because we're going to create predictions of our exponential. And these residuals and residual squared will change naturally. So let's go to insert, and we're going to insert a chart. And the reason we're doing the chart is because that's simply the easiest way to create and to see the equation. So insert chart. Oh, I forgot to select it again. Select these, insert chart. And now there's our nice scatter chart ready to go. And we want to go to customize. We want to go to series. We want to go to trend line. We want to select exponential. And there our exponential line appears. I'm in the mood to change the color of it today. And here is the, there's our exponential. Now, what we're really looking for is the equation. So we want to very key to hit label and want to say use equation. Nice, and actually there it is. Y equals A times E to the kx. So there's our A and our k value that are the coefficients for this exponential. Great, let's calculate our RMSE. So there we go. There is our equation for our exponential equation. And it is an exponential equation. I wonder if it'll be better than the quadratic. Let's see. Now, to create our prediction, we have to understand how to use the exponential in Google Sheets. Well, first of all, we're definitely going to need this A value and this K value available to us in a cell. So let's just type for exponential, that'll work, exponential, and we'll say our A value and our K value. And our A value, now we just need to type this by hand, 2.3, and I should know this, but I'm wondering if Google rounded that 2.3. Well, we're just going to go with 2.3, and the K is 0.0868. All right, there's our K value, our A and our K value. That will allow us to calculate the predictions for this exponential regression. So let's calculate our prediction. Now, to get this prediction to work, we want to have it do A times E to the power of K times X. So A is easy, that's in B15, times E. Now E is the natural number. It's like pi. It's a number that appears in math. So it's a constant. And in Google, you call upon that number by doing exp. And so when you type that, it knows to use that e, and then whatever follows it will automatically be the exponent. So normally, to get an exponent, you'd hit this, the caret, to produce an exponent. But because exp is automatically using e and automatically creating an exponent, you don't need the caret, and you would just type in parentheses what is in the exponent position. In the exponent position is k times x. So our k is in cell C15, and then times our x value, which is in cell E2. Close this, hit enter, and let's cross our fingers that we get a nice prediction. Great, there's a prediction, 2.73. There's our prediction. Now, before we're ready to copy and paste that into all of these cells, we have to lock on to certain values. Which values do we want to lock on to here? Well, we want to lock on to our A and our K. So our A will require some $signs and as well our C. And that's our K. Now notice the E2 stays just natural E2 because we want it to switch to E3 and E4 and E5 as it calculates the predictions for those X values. So that didn't change. And let's paste it down here. All right. This looks good. I know you're nervous with all these big numbers, but all it's doing is just calculating the predictions. And then the residuals, and then the residual squared. Notice our predictions look pretty nice and accurate, actually. All right, here's our residuals. Notice every residual is just the actual minus the predicted. And our residuals our residual squared are nothing more than that, just the residual. So, for example, h6 to the second power. Here's our sum of residuals, and here's our RMSE. It's the square root of the sum, that's in I12, so it's the square root of the sum divided by 6, and that's 6 again because there's 8 data points, and the RMSE formula calls for dividing by n minus 2. So 8 minus 2 is 6. This we don't want because that's the RMSE for the linear, which we've already discussed, so let's delete that. There we go, nice. There's our RMSE. Now that's in cell I14, so we're going to go to sheet 1 and we're going to put it into here, and we're going to say equals a times e to the kx exclamation mark I13. Did I mess this up? I14. Let's copy that, paste that, it's not liking my name. Let's rename this sheet AE2KX. It's, oh, maybe those parentheses is my attempt to get this working. Oh, there we go. All right, we're going to change the name of this one, AB2X. So that's the idea of A times B to the X power. All right, so let's go back here. Sheet, our main sheet. There's our RMSE for the exponential. Notice our quadratic, in this case, actually is doing a better job with a smaller RMSE, so it's more accurate, less error than the exponential. All right, one more exponential form I want you to do, which is the A times B to the X. So in this form, you're finding your A value, but you're also creating a B value that is the base for the X value, the exponent. Let's do it. So here we are. Let's delete these predictions. We don't need these. And let's create this exponential. Now in this exponential, it's a little bit different. If you go to insert chart, insert chart, and you put it, of course, put it back to scatter chart. Of course, use column E as labels. Okay, and now customize, and here's what I want to show you, is that trend line, there's only one type of exponential, and there is a logarithmic, but we're not looking for a logarithmic necessarily directly to a logarithmic equation. We're looking for an exponential equation in the form ab to the x. So let's do that. It's actually not available here. So we close this, we delete this, we go back to the drawing board. Don't need median standard deviation. And actually here, to create this a times b to the x equation, we're going to use built-in Google formula logist. And notice how they give it a nice, very clear name, best fit exponential growth curve. And it's of the form ab to the x. It's funny how Google has the two different types of exponentials. One is available in the chart with the as a label, and the other is available as a formula. Anyway, we're just going to do it. Now, when you do the logist as a formula, it's essential to enter the y values first. So whatever's on the y-axis, enter that first. So we're going to do F2 to F9 because that's the y values, comma E2 to E9. And hit enter, and it immediately produces two values. And I believe our b value, and it's coming back to me. Our b value comes first, and then our a value. So let's label this. This is our b and our a for our exponential. Now, let's create our predictions. What are our predictions? Our predictions are taking this a value times this b value raised to this x power. So let's do it. Equals, and we want to do equals our a value, which I just put in this one is D12, times our b value, which is in C12, to the power of x silly, E2. Cross our fingers that this produces a accurate prediction. Great! This 2.8 close to 3 tells us we're on the right track, and the residual and the residual squared is calculating automatically because that's ready to go with F2 minus G2. If it's not ready to go for you, you can just type in F2 minus G2 or whatever your actual minus your predicted is. Now let's finish these predictions. We want to take this and paste it down here. But whoa, zeros, slow down. Forgot to lock on. We need to lock on to what we want to lock on to, which are our coefficients, our a and our b. Now I actually don't know if b is considered a coefficient here, because coefficient is usually not a value that's being raised to an exponent. But anyway, there we go. We want to lock on to these a and b values. Hit enter. It's not going to change that, but it's going to make it ready to be cut and pasted. Boom, there we go. And these predictions are close. These residuals should all work, and they do. These residuals squared are just the residual squared. Here's our sum of residuals, and here's our RMSE. It's the square root again of the sum of residuals divided by n minus 2. This is the old RMSE for the linear. Don't need that anymore. And there we go. There's our RMSE for the exponential equation of a times b to the x, 0.54. So it's doing a decent job, but not as good as the quadratic or the exponential. So we're going to say equals ab to x, exclamation mark, and we want to pull from that cell this box, which is I13. I13, boom. And there you go. And here are our 4 different regressions: a linear, a quadratic, an exponential, and another exponential. And here we are calculating the root mean standard error of those 4 models. And which one is the best? Which one is the most accurate? The quadratic, because it has the smallest RMSE, the smallest standard error. I hope this is helpful for you. Please send me a message if you have a question.